For 400 years, sailors came back from the open ocean with the same impossible story. A wall of water rising out of nothing. No storm big enough to explain it. No warning at all. Just a single wave, far taller than all the others, steep as a cliff face, moving straight at the ship. They described a hole opening in the sea in front of it. They described looking up at a crest where the sky should be. They described watching the vessel beside them simply disappear. The men on land had a name for stories like that: exaggeration. The fear of sailors who had been too long at sea, too far from shore, too frightened in the dark. A wave like that broke the laws of physics. The mathematics said it could not exist. They were wrong. The wave was real. It had been real the entire time, rising without warning in the deep ocean, swallowing ships and the men aboard them, and leaving nothing behind to argue with. And on the first day of 1995, a single instrument on a lonely platform in the North Sea would finally catch one in the act and prove that every terrified sailor had been telling the truth. For most of history, the deep ocean kept no records. There were only the people who survived it and the stories they carried home. And those stories were everywhere. A sailor describing a sea that suddenly stood up like a mountain. A fisherman swearing a wave had come out of clear weather and crushed the boat next to his. The same account in every language, from every ocean, for centuries. A wave that should not have been possible, appearing where no wave that size had any right to be. Almost 200 years ago, the great Japanese artist Hokusai had already pictured the thing the world refused to see. A towering claw of water, its crest curling into foam, dwarfing the tiny boats beneath it. Many scientists today look at that image and see a rogue wave. Now and then, a witness was hard to dismiss. In 1933, a United States Navy ship called the Ramapo was crossing the Pacific in a gale when its officers, using the ship's own dimensions to sight along the wave behind them, estimated a wall of water more than 110 feet high, over 30 meters, as tall as a 10-story building in the open sea. Even the largest ships were not safe. During the Second World War, the ocean liner Queen Mary, carrying 16,000 soldiers across the Atlantic, was struck broadside by an enormous wave and rolled so far over that water came up over her decks. A few more degrees and she would have capsized, taking more men with her than any single ship in history. And still, the official position held. There was no such thing as a freak wave. The sea did not behave that way. The numbers proved it. Understand why the world refused to believe, you have to understand how scientists pictured the sea. The surface of the ocean looks like chaos, but underneath that chaos is order. A given stretch of water has what oceanographers call a significant wave height, roughly the average height of the largest waves rolling through it. In a heavy storm, that might be 20 or 30 feet. Most waves stay close to that number. A few run smaller, a few run larger. The accepted theory treated those waves like a bell curve. Cluster, most of them around the average, and the chance of any single wave growing far beyond it falls away almost to nothing. A wave twice the height of everything around it was a once-in-a-blue-moon event. A wave that large appearing in a merely average sea was, by the numbers, a once-in-10,000 years freak. So when engineers built structures out in the open ocean, they trusted that math. The oil platforms of the North Sea were designed to take the worst wave the statistics said they would ever face across 10,000 years of service. Anything larger was treated as effectively impossible. That is the crucial point. It was not simply that scientists thought big waves were rare, it was that they believed a wave of the size sailors kept describing, rising out of an ordinary sea, could not form at all. The equations had no room for it. To accept the sailors' stories, you would have to accept that the ocean was doing something the textbooks said was forbidden. For decades, that was where it rested. The sailors had their stories, the scientists had their mathematics. And the two would not be reconciled until the ocean was forced to show its hand. The place it finally happened was not dramatic. It was a gas platform called Draupner, standing alone in the North Sea, about 100 miles off the coast of Norway. Like many platforms, Draupner carried a laser sensor mounted beneath it, pointing straight down at the water, measuring the height of every wave that passed under the deck. It recorded for 20 minutes of every hour, day after day, a quiet stream of numbers no one expected to be remarkable. On the 1st of January 1995, a winter storm was running through the area. The significant wave height that day was about 39 feet 12 meters. A serious sea, but nothing the platform had not weathered many times before. Then, in the middle of the afternoon, the laser caught something. A single wave passed beneath the platform that stood 84 feet tall from its trough to its crest, more than 25 meters. And it came out of a sea where the waves around it were less than half that size. It was larger than anything the platform had been built to survive, and it struck with enough force to damage equipment high on the structure, damage that matched the reading exactly. For the first time in history, a rogue wave had been captured, not by a frightened eyewitness, but by a scientific instrument. A clean, undeniable record printed in data. When researchers studied that reading, they understood what they were holding. The sailors had not been exaggerating, they had not been confused. The wave they had described for centuries was real. It obeyed no rule anyone had written down. And it had just appeared on an ordinary winter afternoon in a sea that was not even at its worst. The Draupner wave changed everything. Scientists knew what to look for. They began to reread the long record of ships that had vanished without explanation. For generations, the disappearances had been blamed on storms, on overloading, on simple bad luck. But some of them fit a darker pattern, vessels lost in weather they should have survived, wreckage that spoke of a single massive blow. In December of 1978, a German cargo ship called the München, one of the most advanced vessels of her kind, sent a garbled distress signal from the middle of the North Atlantic and was never heard from again. All 28 crew were lost. When searchers reached the scene, they found almost nothing except one of her lifeboats. It had been stowed 20 meters above the waterline, and it had been torn away, its steel mountings bent as if something vast had reached up out of the sea and ripped it loose from above. No ordinary storm that night could fully explain it. To this day, the leading theory is a rogue wave. The great passenger ships were not immune either. In 1995, the same year as Draupner, the liner Queen Elizabeth II ran into a wave during a hurricane that her captain put at around 95 feet. He said it looked like the white cliffs of Dover coming straight at the ship. In 2001, in the South Atlantic, 2 cruise ships were struck within days of each other by walls of water near 100 feet high. Both had their bridge windows dozens of feet above the sea smashed inward. One of them lost all power and drifted, helpless and dark, for 2 hours. These were not stories anymore. They were incidents logged and investigated. The wave that could not exist was breaking ships apart. So, how does the ocean build a monster like this? For a long time, there was no good answer. Scientists now believe rogue waves can form in more than one way, and the explanations are nearly as strange as the waves themselves. The simplest is timing. The sea is never a single wave. It is many overlapping trains of waves of different heights and speeds traveling in different directions. Most of the time, they blur together into ordinary chop. But every so often, by pure chance, a group of them lines up in the same place at the same instant. Crest stacking onto crest, and for a few seconds, they pour all of their energy into one towering wall of water. Then they fall out of step, and it is gone. In some places, geography loads the dice. Off the southeast coast of South Africa runs the powerful Agulhas Current, sweeping south while storm swells drive north against it. When a fast current slams into oncoming waves, it squeezes them and steepens them, focusing their energy like a lens. That stretch of coast has become one of the most notorious rogue wave graveyards on Earth. And then there is the strangest mechanism of all. Under certain conditions, a single wave can turn unstable and begin to draw energy out of its neighbors, growing taller as the waves around it shrink away, until one wave looms over a suddenly flattened sea. It may be what sailors meant when they spoke of a hole in the ocean, a deep trough opening in the water just before the wall arrives. Scientists still argue about which of these matters most out in the real ocean, but they no longer argue about the result. Under the right conditions, the sea can, with no warning at all, gather itself into something enormous. After the two cruise ships were hit in 2001, European scientists decided to stop waiting for the waves to come to them. They would go looking from space. The project was called MaxWave. Using two radar satellites already orbiting the Earth, researchers scanned the surface of the world's oceans, breaking the data into tens of thousands of small snapshots of the sea, each one a window a few miles across. They expected rogue waves to be rare. They were braced to find a handful, if any. In just 3 weeks of data, the satellites found more than 10 individual giant waves, each one over 80 feet tall, scattered across the oceans of the world. That single result quietly rewrote the problem. These waves were not freak accidents that struck once in a lifetime. They were happening, somewhere on Earth, all the time. The ocean was throwing up monsters on a regular basis, and almost always in empty water, with no ship and no instrument anywhere near to record them. It cast every unexplained shipwreck in a new light. In the 2 decades before the study, more than 200 large vessels had been lost around the world, roughly 2 enormous ships every week, to all causes and combined. No one could say how many had met a wave like the ones the satellites were now finding. But for the first time, scientists had to take the possibility seriously. Some of the ships that sailed over a calm horizon and never came back may have run into a wall of water that no one survived to describe. The sea had been keeping a secret hidden in plain sight across the entire surface of the planet. We had simply never had the eyes to see it. In the years since, the science has only grown stranger and more humbling. Researchers have learned to build rogue waves on demand in long water tanks in the laboratory, and even in the form of light inside optical fibers. The same mathematics that describes a wave towering over a ship turns out to describe sudden bursts of energy in completely different systems. A rogue wave, it seems, is not only an ocean phenomenon, it is something deeper, written into the way energy can pile up in a wave, anywhere in nature. And the ocean keeps setting new records. In November of 2020, a measuring buoy off the coast of Vancouver Island in Canada recorded a wave 58 feet tall. On its own, that is not the tallest rogue wave ever measured, but the sea around it that day was gentle, with waves only about a third its size. Measured against the calm water it rose from, it is the most extreme rogue wave ever recorded, a 4-story wall of water that climbed out of an ordinary swell. Which leaves the one question that still matters most. Can we see them coming? For now, barely. Scientists can tell you which conditions make rogue waves more likely. They can map the dangerous currents and the risky seas. But predicting the actual wave, the specific wall of water about to rise under a specific ship, in time to do anything about it, is still beyond us. They form in seconds, they vanish in seconds, and the ocean is very, very large. We have proven the monster is real. We have measured it and built it and recreated it in a beam of light. We still cannot tell you where the next one will be. Think about what that means. Right now, as you watch this, somewhere out on the open ocean, the sea is gathering itself. Wave trains are drifting toward the same point. A current is bending a swell. Energy is quietly stacking up in a patch of water with no name and no witness. For 400 years, we told ourselves these waves were a sailor's superstition because the alternative was harder to live with. That the ocean we cross every day, the one that carries our ships and our cargo and our holidays, can without warning rise up 100 feet from an ordinary sea and come down on whatever happens to be there. We were wrong to doubt the sailors. They had seen the truth all along. The wall of water was never a myth. It was simply happening where we could not see it. In the vast and indifferent middle of the sea, the part of our own planet we still understand the least. We have finally learned to measure the monster. We have not learned to predict it, and every day ships still sail out over water that can, at any moment, decide to stand up. The ocean, as it always has, keeps its secrets. If you want to keep descending into those secrets with us, this is Blues Below, where we explore the ocean's deepest mysteries, one story at a time. Subscribe and follow along, and we will see you out on the water.